In this segment, we describe how filling yarn is actually inserted into the fabric. Several systems are used to insert the filling. These include shuttle, rapier, projectile, air jet, and water jet. The shuttle loom was the first type of power loom developed. It uses a shuttle that is a boat-shaped device that holds a small quill of yarn. The shuttle is the only powered insertion system that carries its own yarn supply across the warp. The maximum speed of these looms varies with the width of the fabric, but most produce between 150 and 200 picks per minute. Rapier filling insertion is one of the most versatile of insertion types. This is due to the rapier head gripping the yarn and carrying it across the width of the shed. Therefore, any yarn, from extremely fine to very coarse, can be woven. Also, very different yarns can be woven from pick to pick without readjusting the rapier. There are 4 types of rapier systems: single rigid, double flexible, and double telescoping rapiers. The single rigid rapier uses a solid rod material that carries the yarn completely across the warp. This loom footprint requires twice the floor space of the rapier due to the fact that when the rapier is not in the shed, it is housed in a sheath external to the shed. Double rigid rapiers use 2 rapiers that are just over 1/2 the width of the warp. Each transfers the yarn halfway across the warp shed. This still takes up the same amount of floor space as a single rigid rapier because each rapier is stored on either side of the loom. However, the speed can be increased because it takes less time to insert a pick, since each rapier has only half the distance to travel in the shed. Double flexible rapiers use a flat metal tape or high-tech composite material to transfer the yarn across the warp shed. The advantage of this system is that the floor space is reduced since the rapier storage space is reduced. Because the rapier is flexible, it is coiled into a circular sheath when not inserting the filling. The rapiers are much lighter, resulting in higher processing speeds. Flexible rapier looms are capable of reaching 850 picks per minute on single-width fabrics. Double telescoping rapiers use sliding or telescoping devices to insert the filling yarn. They're similar to double rigid rapiers, but since they telescope, much of their length is stored inside the rapiers themselves as the rapier collapses, thereby reducing the width of the loom. This type of rapier loom can only achieve a maximum of 350 picks per minute due to the weight of the rapier and the time required to extend and contract it. The projectile filling system uses a small bullet-shaped object to carry the filling yarns across the warp shed. The bullet, or projectile, is similar to the much larger shuttle in shape. However, the projectile does not have a self-contained yarn supply. The projectile must be presented with a yarn which it grips just before it is propelled across the warp shed. A projectile is presented to the picking arm and is fed a yarn. It is then fired across the loom through guide teeth to where it is caught in a braking device. It is then returned to the picking station by way of a conveyor chain. Several projectiles are in use at any time so that rapid pick insertion can occur. Air jet filling insertion uses a stream of high-pressure air to insert the filling yarn into the warp shed. This is the fastest conventional method of weaving. Air jet looms consistently reach production speeds of up to 1,000 to 1,200 picks per minute on single-width fabrics. Air jet looms require very expensive profiled reeds to channel the air and yarn across the shed. Air jet weaving inserts the filling from an off-loom auxiliary supply system that accumulates the exact amount of yarn needed to travel across the shed. An initial burst of air starts the yarn on its way, and several auxiliary nozzles then help propel the yarn completely across the warp. These auxiliary nozzles are evenly spaced and fit into the tunneled or profiled section of the reed. Water jet filling insertion uses the same concept of filling insertion as the air jet, Water is used instead of air to project the filling yarn across the warp shed. Due to the higher density of the water jet as compared to the air jet, booster nozzles and profiled reeds are not needed. Speeds of water jet insertion rival those of air jet weaving. One shortcoming of water jet weaving is that only hydrophobic fibers can be used. Multi-phase insertion is the newest technology for inserting picks into the warp shed. This system uses a series of 4 air jets on a rotary drum to reach a pick insertion rate of up to 2,800 picks per minute on basic plain weaves and twills. Due to its complexity and ability to do only very simple weaves, very few multi-phase weaving systems are in use.